Today I'm going to show you how to swipe between panels. There's something really satisfying about swiping between the apps on my phone. I really like this effect and I want to recreate it for Unity. Personally, I want to use this effect for a level manager, but the possibilities are really endless for this sort of thing. So go ahead and open up Unity and let's get started. Right now in Unity, I have a vertical scene set up, but this concept can be applied to any screen layout. Additionally, I have 7 panels loaded into a canvas, and each one contains a series of buttons. I plan to make a future video on how I set this up through code, but for now, let me just show you real quick how to do it manually. First, you need to create a canvas, so right-click and select UI Canvas. Then you need to add an object to hold all of your page elements, so inside Canvas, right-click and select Create Empty. Then inside your empty object, right-click and select UI Panel. This will be the content of your page. This can contain anything, and in my case, it contains a series of buttons resembling icons. Then I just duplicate these panels and move the X position so they are spaced out evenly. If we go back and look at my example, you will see I have 7 panels, and the goal here is going to be to move my panel holder object horizontally to expose the next page. And now that we have our scene set up, we are ready to start coding. Before we begin, I just want to remind Patreon subscribers that you can download this entire project from our Patreon portal. But if you aren't subscribed yet, don't worry, you can copy and paste the code used in this video from our website, pressstart.vip. Okay, let's start coding. The first thing we want to do is create a new C# script called Page Swiper. Then go ahead and drag it into our panel holder object and open it up in the editor. For this script, we are going to use Unity's built-in event system. So up at the top, let's write using Unity Engine.event systems. Then to the right of our model behavior, we want to include 2 classes. The first is called iDragHandler, and the second is called iEndDragHandler. Make sure you spell these exactly as I do, or you're going to have problems with your code. These 2 classes allow us to use built-in functions to detect when a touch is being dragged and when a drag has ended. So let's go ahead and define these below, and again, be sure to spell these exactly as I do. For the first one, write public void onDrag and pass a pointer event data parameter called data. Then for the second one, write public void onEndDrag, and for the parameter, write a pointer event data called data. In both cases, this data variable contains important information about our drag. But the only information we are going to need for this script is the current position of the drag and where the drag started. So let's write these values to our console to test our drag. In the onDrag function, write debug.log, and then parentheses write data.pressPosition minus data.position. Then if we go back in Unity and press play and then start dragging our panel, we should see an X, Y, and Z coordinate of how far we've dragged from the start of our drag. Back in our code, we're going to use this value, but we only care about the X value. So let's remove our debug.log line and create a float called difference and then set it equal to data.pressPosition.x minus data.position. Then we want to move our panel in the direction that we are swiping. We can do that by taking the position of panel before we started dragging and subtracting it by our difference. So before we do that, we need to store the current idle state of our panel. So up at the top, let's store this in a private vector 3 called panel location. And then let's define the position in our start function by writing panel location equals transform.position. Then with that information stored, we can go back to our onDrag function and write transform.position equals panel location minus new vector 3, and for the X parameter put difference, and just go ahead and zero out the rest. This is just a quick way of subtracting the idle panel position with the distance we dragged. Then we want to update our idle state when the drag ends to a new idle state. So in the onEndDrag function, write panel location equals transform.position. Now if we test this back in Unity, we can successfully drag our panel on the X axis. This might work for a lot of cases, but I'm more interested in creating a swiping panel much like that seen on an iPhone home screen. In order to do that, we need a couple of different elements to make it perfect. Firstly, we need a drag threshold to detect how far we need to drag across the screen for it to be considered a swipe. So up at the top, let's define a public float called %threshold, and let's give it a value of 0.2. Then in our onEndDrag function, let's calculate the percentage that we swiped in relation to the width of the screen. To do that, let's take our difference and divide it by our screen width. So let's write float percentage equals, and then in parentheses write data.pressPosition.x minus data.position.x, and then close the parentheses and divide it by screen.width. Now if we swipe from right to left, this value will be positive, and if we swipe from left to right, this value will be negative. But first we want to compare this percent with our % threshold. If the percent swiped is greater than or equal to our percent minimum, then we want to slide to the next page. So let's write if mathf.abs and in parentheses write percentage and then greater than equal to percent threshold. We use mathf.abs here to get our absolute value, so we don't have to write multiple if statements if our percent value is negative. Then we want to set up a new location for our panel to move to. Let's go ahead and define this as a vector3 new location and set it equal to our idle state, which is defined as panel location. And then let's see if our percent is positive by writing if percent is greater than 0. If so, we want to set our new location to a plus equal to a new vector3 and put negative screen dot width for the x value and 0 out the rest of the values. Then we want to reverse this for a negative percent, so let's write if percent is less than 0. And then below that write new location plus equals and new vector3 and put screen dot width for the x value and again 0 out the rest. And then underneath these two if statements, let's move our panel to the new location by writing transform dot position equals new location. And then let's update our idle state to this new location also by writing panel location equals new location. And to finish it off, let's write an else statement to make our panel jump back to the original location if we don't swipe above our touch threshold. So let's write else and then below it put transform dot position equals panel location. Now if you go to test this, you'll be able to swipe between pages, but the process isn't smooth at all. In fact, you might get confused if the page is swiped at all. The reason for this is because our position jumps to either the new location or an idle state without showing the transition between the two. So let's program a smooth transition using an easing effect. To do this, we're going to use a quarantine, which is basically a function that can be run across multiple frames. This is important because we want to animate our transform's position from point A to point B. To set this up, let's write IE numerator and let's call this smooth move. Then let's pass 3 parameters, with the first being a vector3 called startPOS and a second vector3 called endPOS, and then the final parameter is a float called seconds. I'm going to move through this a little quicker, but basically this is going to move a position from startPOS to endPOS in the amount of seconds we define in our function. So go ahead and write float t equals 0f, then create a while loop and put t is less than equal to 1.0. Then we're going to increment t by time.delta time divided by seconds. And then for the fun part, let's move our object by writing transform.position equals vector3.lerp and then parentheses write startPOS, then endPOS, and then we're going to use a mathf function called smoothStep, and let's put 0 for the first parameter, then 1 for the second parameter, and for the final parameter, put t. Then we want our function to wait for the next frame before continuing, so let's write yield return null. Okay, now that we have a function to smoothly move our object from point A to point B, let's replace it in our code. But before we do that, up at the top, let's define a public float called easing, and let's give it a value of 0.5. We will use this to determine how long in seconds we want our panel to ease into the location. Then in our onEndDrag function, let's replace transform.position with our coroutine. So go ahead and write start coroutine and in parentheses write smooth move, and for the first parameter put transform.position, and for the second parameter put new location, and for the final parameter put easing. Then we need to do this again for the part where our panel slides back to its idle position. So again, let's write start quarantine and parentheses put smooth move, and then again for the first parameter put transform.position. But this time for the second parameter put panel location, which is our idle state, and then finish it off with easing for our third parameter. And there you have it. You have now built a script that allows you to swipe between pages. Feel free to adjust the percent threshold and easing values to work best for what you need in your project. In an upcoming video, I will discuss how to create these pages on the fly using code and how to limit this page script from swiping to an empty page. So go ahead and subscribe to this channel so you don't miss that future video. And if you want to download this project, including the artwork that was used, become a member on Patreon. All Patreon subscribers have access to all of the projects that are used in these videos, plus a lot more. Thank you for watching, and I will see you next week.